Hello, CNC Dude here in Venice, Florida, Gulf Coast of Mexico. It's 91 degrees. My pool's about 86, but it still cools me off. All right, we just did number 3 here, this drawing of this cap. Now we want to do the programming for the machine, the CAM part. So, which is computer-aided manufacturing. So we can put it in a control like that Haas control back there or a real machine. So, all right, let's get this out of the way. We got our model. We already have the model done. So now we need to do machining. All right, we're going to switch to manufacture, right? And we got milling, turning, additive, inspection, fabrications for more sheet metal and utilities. We want to be in turning. Turning is also lathe. It's turning around. That's what they call a turning center in the business. All right, we're going to go. We got setup, turning, part handling, drilling actions. So we don't have part handling is for a dual spindle lathe. So we're not doing that. Okay, let's start with the left here. Start with the setup. New setup right here. And notice it does a suggestion already. It's got material around it already. The z-axis is pointing towards the front. Good. The x-axis is pointing towards us. Good. And a typical CNC lathe only uses x and z-axis for positioning. So that's where we're kind of trying to set up the positioning. All right. If you did not pick milling and you would, all right, here, notice it picks a square box. So we were like, no, we want turning. All right. Let's go down the list. Primary spindle, yes. Orientation is good, but we can go over how to reset that if it's not good. Safe Z, stock front, these are called defaults. I would leave it at the default. Spun profile, this is for, it's really not needed on this one, but later on we'll show you how that's important. I'm going to just shut that one off. And this is the default for model back, which means this is the front of the model. This is the back of the model. I'm going to leave that at -0.4. Now it's material size time. All right, we got these selections. And we're not using boxes. We're going to use cylinders. So we got fixed or relative. Relative is like based on the material. I'm going to use fixed. I know what material size I'm going to use. It's suggesting too, but my Haas ST10 CNC lathe can hold up to 1.75 on the inside. I'm just going to go smaller, 1.750. And now that's enough material to work with. All right. We need some material to hold on to the back. So I'm going to extend this to 3.0. And I'm going to do model position from front, and I'm going to offset it 0.05. Just give myself a little extra there. And maybe you have enough to hold on to the back, but we'll deal with that later. Post-process tab, an often overlooked tab here. Program name and number. We want number. Haas machines like number. 1001 is the default, but if you decide you want different numbers, you can put them in there. This is very important because if you're in a shop where you're all doing the same thing, you're all doing the same numbers, you want to know it's your program. I'm going to put up on here, end cap up 1, PD for pokey. WCS is going to be number 1. Hit OK. The setup is now done. I'm going to hit File, Save. All right, now I'm going to do some machining right here, the turning section. These are the popular ones, and this is the whole list. In lathe world, you don't really need a lot. So we have facing, roughing, finishing, grooving, adaptive roughing, more grooving, just a single groove. We got threading, chamfering. And I've used this a lot with parts that did not have chamfers on them. And turning part. This should really be renamed cutoff. But parting is parting the part off the material. So this is, you're making the complete part. part. All right, so it's not turning the part around. So I'll talk to them. All right, we're gonna do facing, turning face. But we need some setups here. We need some tools right up here. Tool library. Now, previously, my instructor had given me a set of tools, and he said put them in the cloud so you always have them. It doesn't matter what machine you're on. You can use the Fusion library, but I like having a set of tools that I know what I'm using with. Let's go down the list here. This is called the active setup. This is anything you store locally. I happen to have some, but the cloud I find is very good. All right, let's go to cloud. Local, okay. And then we can work from there. I'm going to hit close. All right, I'm going to do facing. All right, I'm going to go select a tool. Go to the cloud. I don't see anything in my cloud. Let me go to local right now. Oh, you know what? I think I have to go back. I know why this happened. I am in the school team here, and this is my pokey team. So if you're working in a school, you can work in your own independent team, but the instructor really can't see what you're doing. So I have pokey work out of the team. But let's go back and make sure pokey has his tools. I'm going to switch teams. Right, pokey's folder is going to go back to the last one. Go into assets. Go into tools. Immerse to learn lathe tools. Okay, they're there. Let's see if they're. I'll go back to the. Now you can't copy and transfer stuff from each team. You have to export and import. So, all right, we'll get into that later. Okay, so we're gonna pull up the part, the end cap right here. Back, everything's saved. Close that up. We're still in turning. I'm gonna do facing. Select cloud. There it is, right there. All right. Immerse ITL CNC lathe tools. This is a list of tools, a lot of numbers of stuff. It says tool category and filters. We got turning general, boring, grooving, threading. Pretty simple. Let's go turning general. There we go. We got 3 different tools. A C, a D, and a V. We're going to use a D. D is a 55-degree tool. The V is little skinny thing, 35 and 80s for big roughing. We're going to use the middle one here, D. And I have right here, aluminum RPMs, roughing. We're doing roughing. And the lathe likes to run in surface feet per minute. We'll get into that later. I'm going to hit select. All right, so we go down the list here. I got preset of aluminum, which fills in all this surface feet per minute. It says right here, use constant surface speed. That's how lathes run, and there's a feed rate per revolution. So we'll get into a feed and speed lesson later. So I'm going to go down the list here, go to tab 4, geometry. Now you have, where is it identified from? Lathe is pretty simple. Model front. That's all we need. Clearances. These are where the tool is going to start from and finish. These are all standard settings from Fusion. I would leave it alone if it passes. I'm going to leave material on the front. I'm going to leave 4 thousandths of stock. This is a facing cut, so it just does the front. And I'm going to pick all these defaults. All right. And it says face right there. So my orientations, in my CNC machine, it's this pointing up would be X. Now I'm going to hit, where the heck am I here? Oh, where is it? Right. Simulate. I'm surprised I wasn't up there. Let's go over some settings here. We got tool holder transparent, tool path. I'm going to do tail. I like doing tail. Stock is identified. And opacity. That's the model. I'm going to do right there. Hit play, cuts the front. Notice it turned green. All right. Exit simulation. So it did what we wanted it to do. Now let's do the outside. We're going to do roughing. Right. Same tools already selected. We're doing outside. These are all standards. I'm going to use preset aluminum roughing. Number 2 is, what am I machining? Anything in between here and here. Model front to model back. I like to stretch it a little bit further for the parting tool, the cutoff tool. Some people use tangential extension or use offset. I'm going to do offset minus 0.2. That moves it back a little bit. Okay, tab 3, stock. I'll leave all that alone. Tab 4, passes. We're doing horizontal passes, yes. We're going front to back, yes. Allow radial grooving. We don't really have grooving, but I'm going to use don't allow grooving. And we're leaving material. These are the defaults, so I would leave those just the way they are. And hit OK. Let's see if this works. Aha! It did work. All right, let's go back to, where the heck does simulation go? Simulate. Hit play, cut that, and start roughing. Here we go. Notice it turned colors. So it's the second operation is blue. Looks good. We also, let me put stop on collision on. And yeah, exit. That'd be a good thing to have. Okay, we need to do finishing. All right, so I'm going to go to turning face again. I'm going to use a different tool for finishing. I'm going to go to ITL Lathe Tools, General. I'm going to pick that little V tool. And notice it's got a smaller shape up here. That's a 35-degree shape. We can use finish feed rate, which is actually slower, same RPMs, but same different feed. So we have a nice finish. All right, that takes care. We got surface feed at 800. Maximum spindle speed is how fast the machine can possibly go. And 4,000 per rev. Okay, geometry is selected already. We're doing facing. We're really doing the same thing as before. No stock to leave. Hit OK. All right, got face. Notice it says tool 2 and tool 3. We don't need to do roughing. We do finishing now. All right. Same tool, same feed rates. Geometry is the same. I'm going to change the back to be minus 0.2. That stretch back, yep. Stock. Yep, that's good. No stock to leave. We want it to be finished. Don't allow grooving. Hit OK. Looks good. What is this thing? Lead out has been modified to degauge with remaining stock. Oh, I know what that is. It's sort of thinking it might gouge here. I think I've learned over time that we call these lead in and lead outs. And this one says use the same procedure as lead in. I'm going to uncheck that. And what I usually do is make this 90 degrees. Hit OK. And then the little warning goes away. So it means that as it exits, it's going to go 90 degrees instead of 45 degrees. All right, let's go back to home view again. I'm going to hit simulate again. I'm going to change this from operation to comparison. Notice this little, it says different things. And I'm starting at the wrong place. I got to start at the beginning with all this material. To simulate, comparison, hit play. Now this is sort of a view from a Haas TL lathe sort of view, like normal lathe, I guess you'd call it. All right, green is good, red is bad, blue means there's extra material. There it is, done. We just need to cut the thing off. Exit simulation. This is where parting comes in, not part handling. Parting. Part. I'm going to use a tool. Let's go to the tool library, ITL. It's actually considered to be a grooving tool. And even right there, put 3mm parting tool. I'm going to use number 7 with the feeding speed of 400 feet per minute and the feed rate of 3,005 per revolution. It says right there, parting, model back, edge break, and I'm going to leave material in there because we're going to remachine the back when we do the threads. A parting tool does not really give you the finish you want for a finished part. So I'm going to leave a little bit on there, hit OK. All right, notice it cut it off, right? Now if I go to normal, like lathe orientation up that way, let's start from the beginning. Simulate, hit play. There we go. Roughing, roughing, roughing. Now you can slow this down if I hit pause, and this would be single blocking or next move, right? Pink, pink. It is our cutoff tool right there. Next move, cutoff. Notice it. You gotta make sure these are all set up right. You do have a long enough tool to get in there without it hitting, and the part will fall off. Continue on and retracts and pulls away. Didn't crash into anything, right? Of course, the part will not be there, so that's good. That's everything. Yeah. All right. Let me hit a file save while we're at it. Now it's G-code time. We can also do setup sheet. Setup sheet. This is asking me where do I want to store it. I'm just hit select folder. All right. And right there's my setup sheet. I got the way Fusion does it, it doesn't tell you the round diameter. X and Y represent the round diameter. So they're saying you need 1.75 diameter, about 3 inches long or longer. And using tool number 2, 3, and 7 for operations, cycle time right there. And these are your tool list and operation list. Personally, I don't really need the operation list for setup. I just need what tools and where, how far do I stick this out? That's probably a good point to make right now. How far do we stick it out from the vice jaws? And I really should put a 3-jaw chuck in here to simulate better, but I'm actually going to make a note here. I'm going to do manual NC note. I'm going to do comment, and I'm going to say stick out equals 3.00. Hit OK. I'm going to move this right up top, and I'll show you why. Hit file save. I can also put it in my notes, edit notes. Stick out equals 3.0. 3 zeros, all right. All right, because when I go back to the setup sheet and make a new setup sheet, right there I have notes, stick out 3 inches. All right, I got it there. G-code time, G-code. All right, we're not using machine, but we need to have a post. Now, choose some library, right? We have the Fusion library. In the cloud, I have the machines for my school. So I can have the machines for my school, which is really handy because we're all doing it the same way. Or if you had the big list here of turning and find the machine and which machine do I... Look at all the machines here. Do I have a 10? Do I have a 10L? But you can pick one of these. Let's just use the 10. 10's the one we have. 10. Hit select. Copy to my post. All right, it says right there, post SD10. I got my program number. I got my comment here, by the way. Post the Fusion team. I'm not going to use that. I don't like using the NC file sometimes. All of this we'll leave alone and do create in browser. Hit post. All right, it's going to save to my USB or wherever I decide to put it. And it should have, let's see, open. Oh, no. Sorry, I had the wrong one. I'll leave them both on. I have the wrong one selected. It's updating the old file. And here we go. Bang. Review of the file. Now I notice it says end cap, stick out 3 inches. There's some information here. So let me go back to the G code area. I'm going to go back in here and choose in my school, the school one, this one here. Hit select. Output folder does not exist. It's prompting you to put it somewhere. So if you had a USB, you'd have this automatically selected. Hit post. Overwrite yes. And in ours, we actually have it so it's got the machine identified. It's got a timestamp, and it has a list of tools right here. And stick out. And it actually has a code to turn the chip conveyor on it. So, all right, this is a little review of G code, and we can talk about what they mean. We'll talk about that later. Now we're ready to machine. That's it. That's all there is to it. So, and then when we get it set up to the second time, we'll set it up this way. We'll skim this. We'll put the little chamfer on there, and we'll drill and tap the hole. Done. All right. CNC Dude signing off with a little teaser here. Talk to you later.